This is lesson 12, using equations for lines, and this is activity 3, dilations and slope triangles. And in this activity, we're going to use both equations and dilations to figure out where the coordinates for a dilated image, where they're placed, where they go to. So if you take this triangle, ABC, and you use a scale factor of 2, that means that scaling, dilating images means that you're going to multiply lengths. And so what's the horizontal length in this case? That is 2 units. A scale factor of 2, that means this horizontal length, with the center of dilation, by the way, at 0, 1, means the horizontal length is going to go from 2 to 4. So that's not too bad. It's just 2 times this length, 2 to 4. And then the vertical length is going to go from 1 unit to 2 units. So 2 times 1 is 2 units. So let's see if we can figure out where the coordinates are going to be placed, the x coordinate and the y coordinate for the dilated image. All right, so again, this is 2 units. This is 1 unit in length, so the vertical distance is 1 unit, horizontal distance is 2 units. And so the question is, where does this go to? Where do you put that point? Now you can just do it by eye. It's going to go right here just by looking at it, because it's this length, then it's double that length. But we want to know how to do it mathematically in case it wasn't that easy to see. All right, well, the scale factor times 2, and the scale factor is 2. 2 times 2 is equal to 4. So this takes us out to the point that's 4, so I'm going to go out 4 units, the x coordinate, and 1 unit the y coordinate. So far the y coordinate has not changed. It's at the same spot as 1 unit up. All right, so now how far do you go up to place this point? Well, that's the scale factor times 1. This length is 1 unit. So scaling and dilation is all about multiplying by the scale factor. So if the multiplying the length by the scale factor. So if this length is 1, multiply it by the scale factor, it's going to be 2 times 1, or 2 units. So you're going to go from this point up 2 units to this point. So you get to there. So you end up at coordinates 4, 3. Now if you were just to start at 0, 0 here, and say, okay, I'm going to double the x length, and length along the horizontal distance, that's 4, and double the vertical distance, you would end up at 4, 2. But notice that the coordinates really are 4, 3. So we're going to come back to that. Why is it a 3? So this one's 4, 3. This next problem says, well, what if the scale factor is 2.5 rather than 2? All right, the horizontal length is 2 units, so that's 2.5. Scale factor is 2.5 times 2 is equal to 5. So the horizontal length is going to be double. Well, it's going to be the scale factor times 2, which is going to get you out to 5. So 2.5 times 2 equals 5. And notice at this point, the y coordinate is the same. You're just going out along the x-axis here. Well, it's actually 1 unit up, and to the point 5, 1. But this value gets multiplied by the scale factor. The scale factor is 2.5. 2.5 times 1 is equal to the scale factor. So scale factor times 1 equals the scale factor for the vertical length, the vertical distance. Well, if the scale factor is 2.5, that means that this length is going to be 2.5. Well, this is 1 unit, 2 units, and 1/2 units. But notice you end up at 3.5. So why do you end up at 3.5? So another way to look at it is you start at 0, 0 here, you go out. Well, actually, let's just look at it this way. So you start at the center of dilation, goes out 5 units, and up 2.5 units, and you end up at 3.5. So why 3.5? So how are you going to deal with that? All right, so if the scale factor is anything, it just says, so what now if they do not give you a value for the scale factor, they just say use S. Well, the horizontal length is the scale factor times 2, because the horizontal distance to start with in the original image is 2 units. Now it's 2 times the scale factor is I think the way they wrote it. But it's really a scale factor times 2. You're not doubling the scale factor. You're multiplying the scale factor times this value 2. And so it's, the scale factor, we don't know the scale factor. So it's just s in this case. Sorry. So this is just going to be, the scale factor is s. So it's just going to be s times 2. Well, this is what I was saying. It's not really 2s. It's not 2 times the scale factor. It's actually the scale factor times this length 2. But then we write it as 2s for shorthand. So that's confusing, I guess. All right, so subtle point. So the x value, the x length, is going to be the scale factor times 2. And the vertical length is going to be the scale factor times 1, because the vertical length is 1 unit. Well, anything times 1 is that value. So the scale factor times 1 is equal to the scale factor. So the vertical length is just going to be the scale factor. So you go up 1 unit. You would be at this point, and then you would just increase by the scale factor to get to this line. So this distance is equal to the scale factor. We don't know what it is yet. It's actually less than 2, greater than 1. Scale factor 1.5, which would get you to 3. So it's somewhere between 1.5 and 2. All right. So how do you place this point? This point, notice this point is actually, the x value is actually the scale factor times 2. And you usually write that as 2s. So the scale factor times 2, you write it as 2s. But notice that the y-coordinate is the scale factor plus 1. Well, how do you get that? Why is it the scale factor plus 1? And it is in each case. Here's the scale factor for this point was 2. Add 1 to it, you get to 3. The scale factor for this coordinate was 2.5. Add 1 to it, you get to 3.5. All right, so to understand this, let's go back to the equation. The slope is equal to 1/2. So the vertical distance is half the length of the horizontal distance. That makes the slope equal to 1/2. And if you're going to write this equation, look what you would do. You'd write the x value as, in this case, let's say this is xy. This would be, the x value in this case is 2 minus 0. And the vertical distance is 2 minus 1, which equals 1. So if you wrote it as x and y, so it'd be, the horizontal distance would be x minus 0, or just x. That's why this is just x up here. And the vertical distance would be y minus 1. That's why this is y minus 1 up here. So you have to subtract this 1 to be able to write the equation for the vertical distance, which is just 1 unit in this case, because it's 2 minus 1 is 1. Okay, the vertical length, the ratio of the vertical length to the horizontal length, and that gets multiplied by the scale factor. So dilations are just, and using scaling is just all about multiplying the lengths by the scale factor. So the horizontal distance is equal to 2. So that gets multiplied by the scale factor, which is, so x is equal to the scale factor times 2. So whatever the scale factor is, you're going to always multiply it. For this problem, you're always going to multiply it by this 2, because this is the horizontal length, or the horizontal distance. And the vertical distance, which is y, is 2 minus 1, which is equal to 1. So the vertical distance is just multiplying the scale factor times this 1. Well, that's equal to the scale factor. So the scale factor times 1 equals the scale factor. So whatever the scale factor is, that is going to be the vertical distance, because you're multiplying that by 1. Now what you have to do to get to the coordinate is you have to add this 1 unit back. So it becomes the scale factor plus 1 to get back to this coordinate right here. So you have to add that 1 back from the equation. You subtracted 1 to get the vertical distance. Then you have to add that 1 back to get the coordinate. So the x value is the scale factor times 2. In this case, along this axis, y is equal to 1. But then to figure out where the point is on the line, the x-coordinate is scale factor times 2, but the y-coordinate is the scale factor. It's really the scale factor times 1, which is equals the scale factor. But then you have to add this 1 back. This 1 right here has to get added back to get up to that point, that coordinate. So 2 minus 1 shifts. The scale factor times 1 is equal to the scale factor. And you have to add that 1 back. So one more time, subtract 1 to get the length. So we subtracted 1 up here to get the vertical length, which gets multiplied by the scale factor, and add 1 to get to the coordinate. So you have to add that 1 back to get to the coordinate. So as we go through these examples, think about that. Hopefully it will begin to make sense to you. So scale factor of 2. So what happens? So scale factor is 2. This length is 2 units. So the x-coordinate is, because it starts at 0 here, the x-coordinate is the scale factor times these 2 units. So in this case, the scale factor of 2 is going to make the horizontal distance and the x-coordinate 4. So it's going to take it out to 4. So that's both the coordinate and the horizontal distance, 4 units. The y-coordinate is the scale factor times 1, which is just the scale factor. But now you're out here at 4, and if you go out to 4 this way, and the scale factor is 2, you'd think, oh gee, I go up to 4, 2, but then you have to add this 1. So you have to add this 1 back to get to 4, 3. Scale factor 3, so that's going to be the scale factor times 2, which is going to get you out to 6. And then the vertical, the y-coordinate, is the scale factor, which is 4 in this case. 1, 2, which is 3 in this case. 1, 2, 3. But then you have to add this 1 to get to the coordinate. That's 4. What about if the scale factor is 4? Well, 4 times 2, these 2 units, it gets you out to 8. So now I'm at 8. And then the vertical coordinate, the y-coordinate, is just the scale factor. It's the scale factor times 1. So that's going to be 4 units. 1, 2, 3, 4. But then you have to add this 1 back to get to 5. So if the scale factor is 5, that's 5 times these 2 units. Gets you out to 10. That's right here. It's kind of buried. Gets you out to 10. And the y-coordinate is the scale factor, which is 5. But then 1, 2, 3, 4, 5. But then you have to add that 1 back to get to the coordinate, which is 6. So if it's just the scale factor, if the scale factor is s, not a number now, it's just giving you the scale factor as s, the x-coordinate is going to be s times the 2 units. So it's going to be 2s, or I'd rather say s times 2, but really mathematically you should write 2s. And then the scale factor, remember it's the scale factor times 1, so the y-coordinate is just the scale factor. But then what do you got to do? You got to add that 1 back, so it's going to be the scale factor plus 1. So if they give you the coordinates, how do you figure out what the scale factor is? How do you go backwards? Well, every time we've multiplied the scale factor times these 2 units. So to get the scale factor, what the scale factor is from the x-coordinate, you just divide by 2. 9 divided by 2 is 4.5. And if you use the y-coordinate, you still have to get the same scale factor. They are both multiplied by the same scale factor. And so that is the scale factor. If to get to the y-coordinate, you take the scale factor and you add 1. If you're given the y-coordinate to get to the scale factor, you just have to subtract that 1. So that gets you back to 4.5. And that comes from the equation. It is y minus 1. So it's the y-coordinate minus 1. And that gets you the vertical distance. which remember for a scale factor of 4.5 is 4.5. But then to get to the coordinate, you have to add that 1. This is tough stuff. It takes a lot of thinking. I would go through this carefully, think about it, ask questions, try to do it on your own, whatever you can do to understand what's going on. Why do you subtract 1 and why do you add 1 back?